Hello everybody, I'm going to talk to you today in this video about factoring, and specifically factoring some of these different monomials, binomials, polynomials that we've talked about in the last couple of videos. So I'm going to take you through some problems and some examples before I get you started on this assignment here. So today what we want to do in this class is talk about factoring, and GCF is greatest common factor. Okay, so with greatest common factor, factors are the different terms that you can multiply with to get your answer. So, for example, if I had 12, some of the factors that they might have, I usually like to make a little factor tree. I just have to think of two numbers that multiply to get 12. And there's a couple combinations for the number 12. One combination is 2 times 6. 2 times 6 makes 12. And if I take this further, 2, the only factors of 2 are 1 and 2, but 6 has more factors, like 3 and 2. And so now I have 2, 3, 2, all make 12. 2 times 3 times 2 will all give us 12. And if I wanted to, I could do it a different way and look at different factors from 12, and I can say it was 4 and 3 that make 12. And 3 doesn't have any more factors besides 1 in itself, but 2 and 2 make 4. So 2 and 2 are factors for 4. And 4 and 3 are factors from 12. And 2 and 2 and 3 are all factors for 12. And every number always has a factor of 1 in itself. So if I wanted to, I could factor 12 as 12 and 1. So what I'm going to want you guys to do here is to find the greatest common factor of these two terms. So we have these two terms, and we have to try to find what factors match with them. Sometimes there's factors like 2 or 3 that match. Sometimes it's variables that match. If we look at this problem here, we have 14n squared and 5n squared. So we're going to look at the numbers, the 14 and 5, and we're also going to look at the variables, the n's, to see what they have in common. So if we're looking at factors of two different terms, we're looking for what they have in common that we can divide out of them, okay? So that if we wanted to, we could multiply n. It's kind of like doing the opposite of distribution. So sometimes I like to think of it as if they're all in the parentheses here, and with distribution, I would be drawing these arrows in and multiplying something in. But what I want to do is take something out. I want my arrows to go the opposite direction and take things out of them. Okay, so the opposite of distribution is factoring. So in this case, we have 14n squared and 5n squared. 14 and 5, those don't have any factors in common. 14 can be 2 and 7, 5 is just itself. So I'm not going to have a number out here. 14 and 5, I'm going to leave alone. But n squared and n to the fourth, that's 2 n's here. That's n times n. That's 4 n's over here. So I can take 2 n's out of the first term, and I can take 2 n's out of the last term. I can't take 3 because this one only has 2. This one has more than 2, but I have to leave those extra ones alone. So now I can rewrite my answer as n squared, and this first term is just going to be 14 because the n squared is gone. I took that out. And this last term, now that 2 n's are out, only, oh no, stop it. I'm an artiste. Now only 2 n's are left. And so my final answer can be n squared times this group in parentheses, 14 plus 5n squared. So I'm going to, let's try another one. And in this one here, dang it, nope, I don't like that one. Try it again. Here's a good one. So now with these two terms, if you can see, which is why I liked this one more than the last one, 6 and 8 have a common factor of 2. So I can think of, out of this term and out of this term, what am I going to take out? Well, 6 and 8 can both be divided by 2. And N and B, well, those are different variables. I can't take anything out. They're not the same. I need something that's the same. So now that means my final answer is going to have to be 2 on the outside and N3 and, oh gosh, that's an ugly 3. Oh, way better now. And, oh geez, I got to draw another 3. I forgot about this 3. I got too obsessed with my beautiful 3. 4b squared. Now I have this term here, 3n to the third stayed from the first term. In this term, 8 divided by 2 became 4, and b to the second power stayed. So now my greatest common factor, on some of these problems they want this whole thing factored, but on some they ask for just the GCF. So if you're looking for just the GCF, it's 2. 2 is my GCF, my greatest common factor, because that's the only factor that came out. These are what was factored, but this is my greatest common factor. Okay, we talked a lot about factoring. Now we're going to start looking at more and more. If we have more and more expressions, we just have more and more terms to take things out and find the greatest common factor between more and more terms. So if I look at all these, they all have y's in them, and this one has 4, 2, this one only has 1. So I can't take out more than 1 because this is the smallest amount here. So the greatest I can take out is only a 1y. But if I look at these numbers, all of them can be divisible by 2. So maybe I can take a 2 out. Some 12 and 30 can be divisible by 3. What about 18, 3? So maybe I can take out more numbers. Let's try this out. So I know I can take out a y, which will leave my terms as 12y, and this will be 18. That's a short one, make it longer. And a 30y to the third. So I have these 3 terms after I took out a y. So what else can I take out? Let's see, I can take out a 2. So I'm going to change colors here. If I take out a 2, now I've taken out 2y, and now I have 6y, and I have 9, and I have 15y to the third. Can I take out anything else? Yeah, I can take out a 3. So now let's do that. Let's take out a 3. So now if I take out a 3, that's 3, 2, and y. If I multiply all those together, that becomes a 6y that I took out. And now this first term is only 2y because I took out another 3. I'm going to write a 3 here to remember that we're dividing each of these terms by 3, which made our factors go from y, 2 times y, now 2 times 3 times y, which is 6y. And now I have 2y plus 3, and this becomes 5y squared. Beautiful 5 right there. And so now my greatest common factor here is 6y, because I can't take anything else out from any of these. If you wanted to go straight from the beginning, look at these and take out 6y, you could. And you can say, well, let me erase. Nope. If you wanted to go straight from the beginning and take these all with a 6y out, maybe you saw right from the beginning, Mr. Copeland, I know they're all divisible by 6 and y, so I'm just going to take them all out at once instead of doing 3 steps like I did. That's fine. You would say, all right, 12y squared becomes 2y divided by 6, take out a y, And 18y divided by 6 would be 3. Take out a y, no y's left. And 30y to the fourth divided by 6 would be 5. And take out 1y to make it 3. So this is the most factored one, with our GCF being 6y. And I'm not going to spend too long on this problem type, but there's another one where you have multiple different variables. And on this one, you can take out lots of different stuff. You can divide out the numbers and take out the letters that you can. So what do these have in common? They have V and Y, V and Y. They don't have a U each. This one does, so we can't take that out. So the only things that we can take out are going to be a V and a Y, okay? And we'll look at the numbers next. But for V and Y, let's see, this one has 2 and this one has 3. So the greatest I can take out is 2. And for Y, 4 and 5, the most I can take out, the greatest common factor, would be y to the 4th. Now the numbers here, they're both divisible by 2, but I think they're also divisible by 4. If I divide this by 4, I get 7. If I divide this by 4, I get 4. So I can't divide them anymore, but my greatest common factor, when I divide out that 4, v squared and y 4, would be this. So now we're going to look at some of these terms. This is about the same thing, but instead of a list of different terms, they put them together and they're adding. And this is just like distribution. I'm going to look at this. I'm going to put parentheses around them, even though they're not there. I'm going to think, what am I taking out? Oh, that was a lovely arrow. Oh, beautiful. And I can take out a 5. So that means I'm going to have 5 on the outside, 2 on the inside for this first one. 10 divided by 5 will be 2, and they both have ends. So I take an end. 25 divided by 5 makes 5. And this end, if I take 1 out, remains 2. I did this problem a lot faster because I've been practicing so much on this video, and as you guys go, you'll get a lot faster at it too. Okay, so now this next problem type is going to look a little bit different, but it mathematically means the same thing. We have different numbers or different factors that we were getting rid of, dividing them out. And if you look at this one, they do have the same factors here. They have something in common. In this big binomial here, we have 2 terms, all right? We have this term on the left, and we have this term on the right. And what do they both have in common? Well, we have 3 multiplied by v squared multiplied by what's here in the parentheses. On this one, we have 2 multiplied what's here in the parentheses. And if you look outside the parentheses, 3v squared and 2, they don't have anything in common. But v minus 9, these are the same term in these parentheses. So if I want to take those out, I can take out the v minus 9. So now I'm going to have v minus 9 on the outside here, and on the inside, I'm still going to have my parentheses from my inside of this factor. So what's left? If I took out v minus 9 and v minus 9, I have what remains on the inside here, which is 3v squared and a plus 2. And that's what's left. So now this is my entire answer here. All right. We used the greatest common factor, which was v minus 9, and we took that out. And now we can rewrite this expression and it's factored out now that we rewrote it. Now what we're going to do is we're going to factor this one, and it's going to ask us factor it by grouping. Okay? There's different ways to factor it, but by factoring by grouping is we pretty much just pick our two groups. So I'm going to take the first two terms and make that a group, and I'm going to take the last two terms and make that a group. I know my parentheses are beautiful, and they don't obscure any of the work, right? So if I look at these, what I'm going to do is I'm going to try to find common things that they have in common in purple and the common things that they have in common in yellow. So what do my purple terms have in common? My purple terms, I have 3y cubed plus 5y squared. Well, 3 and y don't have anything in common, but the two y's do. And there's 3 and 2, so the most I can take out is 2. So on this one, I'm going to take out y to the second power, which then means on the inside, it leaves 3 and 1y plus 5. If I take out 2 y's from both of those terms, this is what I have left, 3y plus 5. Now, let's look at this yellow term. So this yellow one, if I want to take things out, what can I take out? Well, this term only has a y, this one doesn't, so I'm not going to take out any y's, but I can look at what these numbers might have in common. 18 and 30, I can divide those by 6. 18 divided by 6 is 3. 30 divided by 6 is 5. So if I take out a positive 6 here, then on the inside, I will have a 3y plus 5. And now we have one more step we have to do, and you might already be seeing it right now. Just like the last problem I showed, this term and this term inside the parentheses here are exactly the same. 3y plus 5, 3y plus 5. And now we have this y squared times the parentheses plus 6 times the parentheses. And we're going to take out these two terms from this. And we're going to factor out this. So we just factored these two groups, and now we're going to factor the whole thing together, because now we made two groups. Y squared, let me underline it. We have this group here, the first half, and we have this group here, the second half. And both of them share what I underlined in green here, the 3y plus 5. So let's go with a blue. And if I take out that 3y plus 5, I'll have 3y plus 5 in parentheses on the outside. That went out there. That went out there. And then on the inside of these parentheses, I'm going to have y squared plus 6. Y squared plus 6. So now, as I factored this, I'm going to have 3y plus 5 and y squared plus 6. And I'm going to look at the explanation, and they should have the same kind of thing. Hey, they use blue too. What? So now they have 3y plus 5 on the outside in blue, and they took them out with blue. I'm a genius because I used the same color. Math didn't matter, same color. That's what makes me a genius. Now we have y squared plus 6. Same two factors here that we had. I'm going to show you one more type for this video. This one's pretty much the same as the last problem, but if you notice, there's some negative numbers. Some things change a little bit as we go, and so we're just going to get a little bit more practice. So I'm going to take the first group, and I'm going to make orange for the second group. Try not to write over top of my numbers here. And so now let's see what we can take out. So for this red one, what I can take out, they have y squared in common. 5 and 7, nothing in common. So this will be y squared. Then what remains on the inside will be 5y plus 7. I'm going to switch to orange. And what am I going to take out of the orange? Well, they're both negative, so I can take out a negative number if I want to. And I can take out negative, let's see, 30 and 12. Well, 6 goes into that, right? 6 times 5 is 30. 6 times 7 is 42. All right, so I'm going to take out a negative 6. And if I do that, what's left inside? Well, if I take out the negative 6, negative 30 divided by negative 6 will be positive 5y. And this will be positive 7. Now, if you notice, what should have happened and what did happen is that now we have these two terms identical. If on this orange one, you didn't take out the negative 6, if you just took out a positive 6, these numbers would still be negative and they wouldn't match. So you might notice that, and then you might think, oops, I got to take out the negative sign with it. Sometimes it helps to take out that negative sign so that you have these two green parentheses matching. If the parentheses don't match after this step, you might not have factored all the way. If I only factored out one y, these wouldn't have matched. But because I factored out both of them, now they do. So if I look at this whole thing, I've got my term on the left, I got my term on the right, and I have these two green that are going out. So now I'm going to draw it in blue to make sure my final answer matches the explanation. And 5y plus 7 can be taken out. That's the greatest common factor from this whole big parentheses. So 5y plus 7 came out, and what remains on the inside here will be y squared minus 6. And now going to the explanation, I have 5y plus 7, y squared minus 6. Double checking my work. So this is how we're going to be factoring. And as we go, we're going to get some bigger terms and different things that might have some different challenges in factoring. But these were some of the basics of factoring numbers like 12 all the way to factoring big terms like this.